Hello. If you're watching this, you missed day 2 of our week 7 foundation or computer science principles lecture. Let's get to it. Today we had 2 objectives. One was to review Big O, which was an assignment you guys didn't do so hot on. And the second was to continue our exploration of return and parameters as they pertain to functions. Please don't forget, you do have some deadlines coming up. In particular, 06, 04, 02, the deadline is March 23rd. And then 07, 03, 01, hopefully you've turned in, as it was due Friday. So the first thing to note is the following set of rules when it applies to Big O. It's important to understand how Big O works, but if nothing else, you should have this following framework. Anytime you have a single line operation, doesn't matter what kind of operation it is, you should be thinking Big O of 1. So for instance, if we had something like this, function, my function, and it takes in 2 parameters, let's say, and then it does something with those parameters, like and then even if, let's say, it has a return, all of these are single line operations. The runtime of these things does not depend on any other information, on any size of a particular data structure. This is one operation to add and another one to assign to a variable, so 2. And this was 1 operation. So this is a total of 3 operations, but any number, even if there was 50,000 lines of code here, but they were all single lines, we would say all of this is Big O of 1. It does not change. It's a constant number of operations. So please make sure you understand that. O of n is something that traverses the list once. So anytime you see the following structure, for var I equals 0, I is less than list.length, I plus plus, what you have here, sorry about my typing, is a Big O of n idea. This is Big O of n. Why? Well, this particular loop is going to run n times. So if this is whatever is inside here, any number of single line operations, ultimately this is going to be Big O of n. Now, sometimes you start like this, but then there's something extra there. So anything where you have a nested loop is going to be n squared. So in n squared situation, we have the following outline. It would have a for loop, like so, and then a secondary for loop inside. Well, now you have O of n times O of n. This is O of n squared. Please note that let's say we had all of this. This is now all O of n to the third. O of n to the third would be 3 nested loops. Sequential loops mean add O of n plus O of n squared. Only the largest term matters if you're adding. So in this case, even if I were to include this upper loop and say all of this is one program, and I ask you what is the Big O of this, well, only O of n squared matters. It grows the fastest as we increase n. So it would be just O of n squared. We can disregard this for the purposes of figuring out the algorithmic complexity. Last but not least, algorithmic time arises when a counter is increased or decreased by multiplication or division. So what do I mean by that? We have this kind of structure, but we're going to not start I at 0, we're going to start I at 1, and we're going to say I is equal to I times 2. Well, what that means is I is going to grow at a rate of doubling each time. So we're really going to reach the length of the list in the number of times it takes us to get there using powers of 2. This is logarithmic time. That's what it means to take a logarithm of something, is to find out how many powers of a number we need to get to there. So this is Big O of log of n. This is a really fast time. Now, let's say we had something like this. We had our O of n, and inside we had a big O of n. We have a regular one, big O of n, and inside we have a big O log n. We could switch these up, and it wouldn't matter, actually. What would this be? Well, it would be O of n times O log of n. So this is O of n log n. Hopefully you understand why that works. You have to multiply these together if they're nested. If they were sequential, only the larger term would matter. Only O of n would matter. If you have any further questions with big O, please make sure you ask me. Otherwise, let's move on. So our activity is to continue where we left off with parameters and returns. So we talked about how to set those up. Now let's take a look at the code.org assignment. So inside code.org, if you navigate to Unit 7, Lesson 2 and 3, let's take a look at them together real quick here. Unit 7. Lesson 2 is an investigation. Here you see one new idea, which we haven't talked about, which is taking modulus division of something. What does that mean? Well, first of all, let's see what this program does. Let's say we put in two numbers, 29 and 12, and we'll multiply them together. First of all, it calculates the answer using some functions that take a symbol as a parameter. Also note these structures here for the comments. I really encourage you to please use this idea of letting you know what the type is going to be of that particular parameter, which really helps somebody reading your code, and also letting you know what the function is going to return. In this case, it's string. Now on line 30, you see that they use a modulus operator to determine if a number is even. What is a modulus operator? Well, it's very similar to regular division. But in regular division, when you divide something, you want to know how many times does 2 go into 3? 1.5 times. Modulus division, we use the percent symbol to represent it, means we don't care how many times 2 goes into 3. All we care about is if we fit 2 into 3 as many times as we can without going over, what is going to be left over? We care about the remainder. So this says find the remainder of dividing 3 by 2. So let's see. What's the remainder of dividing 17 by 5? Well, we could do regular math here. 5 goes into 17 3 times. If we subtract 15, then we get 2 left over. So the answer is 2. 17 mod 5 is 2. Hopefully that makes sense to you. There's additional practice with that idea inside your assignment. So your assignment is to complete parameters and return practice, levels 2 through 10. If you have any questions about how to do any of that, please let me know. I believe in you. I don't think this is a particularly difficult topic, but if you run into issue, feel free to send me an email or come to my office hours. I'd be delighted to help you. Have a great rest of your day, and I'll see you later.